In section 7.4, notice the title of our section is Special Products. So the word products, we should recognize that we are still going to be multiplying, except again, we will take a look at these, quote, special products. So the first special product is the sum and difference pattern. So notice a plus b times a minus b. A few things to notice about this to fit a pattern is that the first term in each set of parentheses must be the same. The second term in each set of parentheses must be the same. So when I think of A, I think of the first term. When I think of B, I think of the second term then. Sum and difference, one's plus, one's minus, and notice these each are binomials. Well, in the last section, how did we multiply a binomial by a binomial? We FOILed. So that's exactly what I'm going to do to then discover this sum and difference pattern. So if I do my first terms, a times a would be a squared. My outers, a times negative b, I'll make that minus ab. The inners, ba, but remember order doesn't matter for multiplication, so I'm going to make that ab just because my other term I have a first. And then b times negative b would be negative b squared. Well, usually with FOILing, we look to combine like terms. Okay, fine. Let's look at combining like terms. No other a squared, no other b squared. However, minus ab plus ab, those guys cancel each other out. So all we're really left with is a squared minus b squared. That's it. So with this sum and difference pattern, again, it can't just be a sum and a difference. The first term in each set of parentheses must be the same. The second term in each set of parentheses must be the same as well. When that happens, you are able to just square your first term, minus, and then square that second term. So, if we take a look, my first term I would consider to be my x. So I need to square that x, minus in between, and then square the second term, but the second term is 3. So I would say that is x squared minus 9. Done. That's it. If you did FOIL, outers x squared, or excuse me, first x squared, outers plus 3x, inners minus 3x, last minus 9, but 3x minus 3x, those do cancel. For letter B in the middle there, first term in each set is the same, one's plus, one's minus, and then the second term in each set is the same. So it does follow my sum and difference patterns. Therefore, I am able to square the first term, minus then the second term squared. Well, b squared is just b squared, 9 squared is 81. That's it. For the last one, it does follow our pattern, same term first in each set, same term second in each set, one's plus, one's minus. So I do square the first term. However, the first term is 2x. That whole thing needs to be squared, and then minus the second term, which is just the 7, need to square that as well. Now remember from our section before, it's a product raised to an exponent, so I am able to distribute that exponent in, which means I need to square the 2 and square the x. And 7 squared is 49. So make sure, if you do not have just a plain variable, if there is a coefficient other than 1 on there, make sure you square both the coefficient and the variable. There's your sum and difference pattern. For the square of a binomial pattern, again, I want to discover what this pattern actually is. So binomial means we have two terms, that's great, and we are squaring it. A lot of students want to say, I know, I can just distribute that exponent in and make it a squared plus b squared. Well, if you think back to when we talked about distributing an exponent through, what operations did we say we were allowed to distribute an exponent through? We said multiplication and division. We did say that you are not able to distribute an exponent through addition and subtraction. Again, you are not able to distribute an exponent through addition and subtraction. One more time, you cannot distribute an exponent through addition or subtraction. And let's see why not. Remember, squaring something means you multiply it by itself. So this really means a plus b times a plus b. Well, notice I have a binomial times a binomial. Therefore, I will FOIL. So if I multiply my first terms, a times a squared. My outers, a times b, ab. The inners is the same thing. And then my lasts, b times b, is b squared. Yet again, we can combine those two middle terms. Therefore, my pattern is a squared plus 2ab plus b squared. If you were to just distribute that exponent in, you would miss that middle term of 2ab. Now again, I don't think of it as a and b. I think of a as the first term, b as the second term. Square the first term. Double, multiply by 2, the product of the two terms, and then add your second term squared. For a minus b squared, very little difference between this and the one we just looked at, but again, we'll take a look at foiling. A times a squared, a times negative b, negative ab. Negative b times a is another negative ab. Negative b and negative b turns positive b squared. Again, those outers and inners can combine. This time it's negative 2ab. Notice, the only thing different between those two patterns, plus in the middle when there was a plus in the middle, minus in the middle when there's a minus in the middle. So again, if you want to memorize them in terms of a's and b's, that's great. Or again, when I think about it, I think about a as the first term, b as my second term. First term squared, double the product of the two terms, plus the second term squared. So for letter A, x plus 4 quantity squared. First term is x, square it. Sign in the middle comes, double the product. Well, the product of x and 4 is 4x. Double it, 8x. Plus the second term squared, 4 squared is 16. There's your answer, done. Some people say, whoa, I don't really like this whole pattern stuff. I really like to FOIL, can't I do that? Yes, you absolutely still can FOIL. However, these special patterns are a heck of a lot quicker than having to FOIL everything. For letter B, this time it's the square of a binomial, but it's a difference this time. Still, square the first term. The first term's 3x. You need to square both the number, the coefficient, and the variable both. So 9x squared, minus in between. The product, 3x times 2 is 6x. Double it, 12x, plus 2 squared, or 4. So again, first term squared, either plus or minus, double the product of the two terms, plus the second term squared. Same exact thing for part C. Square your first term, 5z squared. Square both the coefficient and the variable, 25z squared. My product is 20z, double it, would be 40z, plus my second term squared, 4 squared, is 16. And then my last one, back to a difference, so that just means it'll be minus in between. First term squared will be x squared, minus the product would be 7x, double is 14x, plus 7 squared, or 49. So again, when you have the square of a binomial, square the first term, plus or minus whatever it was originally, double the product of the two terms, always plus the second term squared. To show that in an application problem, hopefully that box looks familiar. You've seen it in science class. That is called a Punnett square. It is used to predict or to see what different traits are possible. So here we're crossing two roses. Each one has a red and a white gene. You can use these to see what color eyes somebody might have, what color hair, attached earlobe, detached earlobe, a lot of different things that you can use this application for. So it asks us in part A, what percent, so we're going to get a percent, of the possible gene combinations result in pink? Well, how many pinks do you see? There are 2 out of a total of 4 possibilities. 2/4 is 1/2. Well, what's 1/2 as a percent? It is 50%. So there is a 50% chance when we cross these 2 flowers that we would end up with a pink rose. Now for part B, it gives us an expression that 0.5r plus 0.5w, quantity squared, it asks us to use the square of a binomial to model that possible gene combinations. So I have 0.5r plus 0.5w, and I want to square that quantity. Square the first term. 0.5r squared, you need to square 0.5. 0.5 squared is 0.25, and then square the variable as well. Plus, because it's plus in between, the product of the two, 0.5 times 0.5, you just did that and got 0.25, but it needs to be doubled. That ends up with just 0.5. Bring your variables with you, RW, plus, and you already did 0.5 squared and got 0.25, and then the W needs to be squared as well. So again, the big mistake I'll see with using the pattern is if that variable has a coefficient other than 1, students will only square the variable and not the coefficient. Make sure both terms do get squared. Again, whatever sign is in between comes in between for the square of a binomial pattern. And again, you cannot distribute this exponent through to both of the terms. Again, what happens there is we then leave out and miss that middle term.